Good morning all. In the garden, and I've rigged up a little test bed for the PWM5 gum stick version solar charge controller. I've got a 15 watt, I think that solar panel is, and my little Maplin battery. What was the spec on that? 12 volt, 2.3 amp hours. I suppose that solar panel is a little bit big for that battery. Anyway, I've got the gum stick solar charge controller between the two of them, and it's flashing away merrily, telling me the voltage is about 12.7, 12.8, something like that. And I don't think that solar panel is going to stress that battery much at the moment, because England's gone back to being England again, and it's just horribly cloudy and overcast. Now the problem with this setup is I can see that LED quite easily at night, but I can't see it very well during the day because it's very dim, and that's because I didn't have the 150 ohm resistor to put in series with the LED. I only had a 4K7, which is a bit high for a blue LED powered by 5 volts. So let's get that inside. Let's take that 4K7 resistor off and put one of my new 150 ohm resistors on that board. And I'll also put one on the Femto board at the same time, I think. So before I start, let's change the soldering iron tip, because I really want a little fine point one here. Now I know what people are going to say. Oh, why was the fine point tip ever invented? It's no use for anything, but I like it for surface mount because, well, it's about as small as the actual parts are. Right, let's start this up. It's funny, isn't it? Soldering always seems to bring out the vociferous commenters, what I call the don'ts. Don'ts are people who say, oh, you don't want to do it like that. I do believe you don't want to do it like that. Yes, I actually blocked a don't the other day. I just got so bored with listening to his stupid comments, I couldn't take any more of it. So he won't be making any comments again. Right, let's wait for the soldering iron to warm up. Okay, we go. This little tip does seem to oxidize more quickly than some of the others. I don't know why. Anyway, there it is. That blob's a bit big. Smaller blob, please. Right, let's lift this one off. It should be possible to lift it off just by heating one side. There she comes. Out with the 4K7. Let's get my 150 ohm. Right, oh, that's missold. A couple of 150 ohm resistors. One's going to go on the Femto, one's going to go on the gum stick. Right, okay, I need tweezers. Where are they? Right, let's have flux, because flux is my friend. Flux is my best friend. Flux is probably my only friend, actually, if the truth be told. Right, okay, let's pick one of these little blighters up. 0805, you're probably saying, they're huge! You should try using 0201s. Well, I don't want to. So there it is. Can I just tack that one on without turning the whole thing around? Probably. Right, let's take that out and give it a try. Right, let's reattach the PWM5 to the battery. Can I do this one-handed without shorting it? I hope. Oh, look at that. Look at the brightitude of that LED. Let's wait for the flashes. Yeah, that's much more visible in daylight. Okay, let's have a look at those flashes. 1, 2, and I don't know, 7 little ones. So that's 12.7 volts, and I am liking that much brighter LED. Okay, let's go to the PWM5 Femto. And just another check from inside the patio doors. Yes, we can see that LED quite well. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. About 12.8. Cool. Right, I've soldered the 150 ohm resistor into its position. It's a little bit off center, but it's within the white line, so you know, if a parking warden comes along, I'm not going to get fined for parking outside the white lines there, am I? I think that's good enough. Right, I need to flip that board over and think about, I've got to program a microcontroller, haven't I? Right, I'm going to use this ZIF socket thing on my programmer. Need to find a programmer. Need to find my little adapter from DIP to surface mount. Need to find a USB lead, all that stuff. Yes, I remember how I did this. So I'm going to use this genuine microchip PIC kit too. I do have fake ones as well, but I just thought I'd use that one today. Here are my little PICs, the 12F683. This is what I used to test the chip because there are some LEDs on here and a pot. So I think I tweaked the pot a bit and saw that the LED flashed, that sort of voltage type thing. Yeah, so this is all good. Let's take this SOIC adapter thing off there and poke it in here. I think it goes in the top ones. Is that right? Yeah. It's quite tight in there because the pins are quite thick. Okay, that opens the little gripper leg things. Let's get one of these in there. Right, so that'll go in this way. Pin 1. Oh, that wasn't very good, was it? No, that wasn't very good either. Got all these posts in my way. I don't want posts in the way, but they probably have to be there. Get in there. Oh, there we are. Perfect, that's good. Right, let's plug some USB from my PC into the PIC kit and see if we can program this thing up. Right, well that seemed to program okay. I didn't show the process. I did this once before actually. I might put a little card up there to link to the video where I did this before. Right, let's take that out. And then I think the idea was to take this off, put this thing in this little demo board. VDD I'm pretty sure is pin 1. Push that into there. And if I power this up, which should happen if I flip that over and poke it on there, I should be able to see the LED. Now the LEDs come on. Oh yes, that's right. I think it's inverted because this LED is tied to VCC. So 1, 2, 3, 0. So if I tweak that pot a little bit, I don't think I need to tweak it much. Where's my screwdriver? This screwdriver's the wrong size. Get another screwdriver. Yeah, so let's tweak this pot. Let's take it down a fraction. What do we see? 1, 2, 1, 2, 3. So 12.3. Let's take it up a fraction. Oh, that's modulating, so that's 13.5 or more. Nudge it back. And we should see a higher voltage. I missed that. I missed that. Did you catch that? 1, 2. Whatever. Let's drop it back a bit more to theoretically below 11 volts. That's 11 point something. Let's go back a little bit more. And we get that, which is the steady pulsing, and that means below 11 volts. So yeah, that all looks like it's doing the voltage measurement thing. I think it's time to solder that PIC onto my Femto board and put some power to it and make sure that this LED flashes. Yeah, I'm happy that that's tested and that's working. So let's take that out. Yeah, let's get this chip out. Right, let's try putting the tweezers in underneath it. Oh yeah, that works better. So that's going to go on the other side of this. Pin 1, have I got a marker for that? Yeah, I have. So that'll go that way round. So I'll just tin one of these pads so that I can adhere it, and then I can solder all the other pads. Right, let's tin this one in that bottom corner. Okay, let's get you on there. Don't want to zap it. No, that's the wrong way around, isn't it? Oh, I need to come in from the side. Okay, so let's turn him round. Come in from the side. Place it there. Right, now I need to nudge it into position. Oh, I've got too much solder on there, really. And tack that pin down. Get over a bit. I want you nice and centered. I want you to look nice and presentable for the viewers. Not just all over the shop. Okay, that pin went on quite nicely. Let's solder a couple more pins on this side, or let's do more, why not? Flip it round and solder the other side. Right, now I need to put some power onto this. Probably go for a current limited power supply. Good, that's done. And yeah, see if the LED flashes. How would you like to see the quality of my soldering? There it is. Oh, pin 7's a little bit over blobbed, but yeah, the others are quite nice, I think. 12F683 I/SN is the chip. Oh, soldering iron is still hot. Let's turn that off. Press both buttons. Right, 12 volts, current 1 amp. That's really very excessive because this thing takes next to nothing. So, I don't know, 200 milliamps is more than enough. 210, yeah, why not? 210 milliamps. Right, so these are the ends. This is kind of for Muppet, but I can probably poke these in the holes. Now, which is source? I think it's over there. So, got to be careful here, don't blow this up. We don't need the MOSFET in here, I just want to see if the LED lights. So I'm on the side with the LED. Let's get some power on there, 12 volts. Okay, so ground is on that one. 12 volts is there. It lights up. And now we should get voltage flashes. One, two. So it's saying 12.2. Actually, let's change this. 12 point, yeah, so it's slightly reading high. Now, is that what I was expecting? Because the voltage on the regulator was a bit low. Yes, that would mean it would read high, wouldn't it? Yeah, so that's fine. Let's go down to 11.8. Is this on? It is now. I want voltage on here, really. Right, 11.79, let's try that. Ground is there. VCC is there. So it powers up. 2 second on, then there's a gap. One, two. And no subsequent flashes. So yeah, that's consistent. That's saying 12 volts when it's actually 11.8. So yeah, I'm happy with that, apart from the fact that these regulators are not very precise. There's a 3% tolerance on this HT7550. Oh, there we go. What was that telling me? Was that 11.9? Single flash, 11 volts, and a whole load of flashes. So yeah, 11.9. So it's only about 0.1 volts out. Yeah, I can live with that. That works. Happy with that. One thing I was a little bit concerned about, you see these 4 wires here, they're all very, very close to each other. Well, the top 2 up here are the charge pump. So there's a digital signal on here, 5 volts, which is probably running at about a kilohertz. It might be a few kilohertz. It's hard to say because it's not timed very accurately. It's just instructions in the code liberally sprinkled throughout the code. So it's all a bit noisy there. And then this one down here is actually the A to D signal, because we've got the potential divider here, the 82K and the 20K resistors. So coming in at the top there is battery voltage. The midpoint goes across here. There's this little 220 puff capacitor to just take out any nasty high frequency stuff, and then it goes down through that via. Well, a via is as a cylinder, isn't it? Effectively a cylinder of copper and the coating, the tinning, and it's sitting next to these two cylinders, which are whizzing up and down 5 volts to 0 volts at moderate speed. I was a bit concerned that there might be a little bit of induction across between these 2 points, but I don't think there is. It seems to be measuring voltage quite stably. This one over here I think is VCC, or it might be ground, I can't remember now. But yeah, I was a bit concerned about that. I did put them very close to each other. They had to kind of go there because they live underneath that chip. I wonder if I could move the two for the charge pump. I can't see what's going on under oh, actually I could get another board. Yeah, I don't think there's much I can do about this because the two charge pump ones, which are on these 2 pins of the microcontroller, are right near the bottom of the available space on this side, and then if I flip it over, it's all right near the top of the available space on this side. So short of moving this chip this way, which I can't really do because then it'll interfere with these dual diodes, yeah, it is a bit tight. I don't think I can separate those out, but yeah, it doesn't seem to be causing a problem. Now, a question that keeps coming up time and time again is, why did you use a through-hole MOSFET when you could have used a D2 pack, a surface mount MOSFET, and then you could have anchored it down both from on the pins and the top of the tab? Well, the answer to that is that 2 of these legs, obviously not the gate, but the drain and the source get soldered in but don't get cut off. They get bent over and they actually become the connection points for 2 of the wires, the red wire to the battery and the yellow wire to the solar panel. So the wires are soldered onto these legs. They're bent down and they're soldered on and heat shrunk and made to look nice. 2 more wires will come out through these 2 holes here. They'll just be a piece of tinned copper wire bent over like a little link, and they'll come out, and the 2 ground wires, the 2 black wires, will attach to those. So that's how I'll get my 4 wires into this thing, because there are no connectors, there's no space for connectors. And then finally these outer 2 holes are the transient suppression diode. That component can't be fitted until my little link wire is fitted because it sits underneath. So the transient suppression diode will sit slightly high off the board, but probably won't extend that much higher, if at all, than the MOSFET. So yeah, I think that all looks pretty good. So the MOSFET will be next to go in, solder my wires on, put the transorb in, and then I've got to somehow coat this. And I've been looking at sort of nail varnish. You can get this nail varnish that you put under a UV light to, I don't know, make it go hard or whatever. Don't understand painting nails, it's not really my thing. So if that's a UV triggered varnish, it's probably very similar to that UV glue I've got. So I might just blob that glue all over this, completely cover it in UV glue once I've got my wires on, and see if it'll live outdoors. Remember, I've got 10 of these. So I can try 10 different methods of sealing it from the elements before I run out of PCBs. So I'm going to try all sorts of different methods. Just one thing that's upset me a little bit. I went to great lengths to put the LED in the middle of the board by putting the resistor near the edge. That meant I could get the LED in the middle. And of course I've just realised, well, I realised a little while ago, that when I bend that centre leg back, that's the drain of the MOSFET, it goes to the yellow wire which comes in from the solar panel, it's going to completely obscure the LED. Now, it's not a major thing because plenty of light will come out the sides, and when this is, you know, clear varnished, there's going to be lots of light escapes from this, but you won't be able to see the LED directly because that wire, that anchorage point, this middle pin, will fold over and completely obscure the LED, and I didn't think about that, and I'm quite annoyed. So one thing I'm going to do, and I'm holding this to sort of try and prevent the gate voltage from floating up and killing the gate, I'm going to cut the gate off to about the length of the depth of the PCB. It's not going to be exact, but it's going to be near enough. There, because the gate is not going to be one of my connection points. So that will go through there. The gate I don't really want to extend beyond the edge of the board. Oh, I got that about right. Look at that. Spot on. The drain and source are connection points for 2 of the wires. But yeah, that looks about right. I think I might glue this on actually. I might drop a bit of that UV glue in there, in that hole, and just glue this on, ready for soldering it. Yeah, perhaps I'll do that. Look at this. I knew this little tie clip would come in handy one day. It's holding my MOSFET on there, so I can drop a little bit of glue into that hole, wave the UV torch around over the top of it. Let's give that a go now. Right, here's this mucky one which is leaking a bit, but squirt a bit of glue in that hole. Oh, why isn't it coming out? Has daylight got in and made the whole thing go hard? Yeah, that's not coming out. What's going on there? Oh, well, I got some more of these, so let's switch to another one. This one. Oh, that's got a little cap on it. Okay, let's try this one. Yeah, there's a blob. It's attached itself to the MOSFET and the board. I'm happy with that. Where's my torch? Here it is, bit of UV. Just blocking it from my eyesight because I'm not sure what type of UV this is. A, B, C, or whatever. Try and make that UV glue go off so that MOSFET now won't fall off the board when I'm trying to solder it. Just helps to anchor it on there a bit better, doesn't it? Okay, that's probably enough. Right, so let's solder this MOSFET leg in there. Don't need much solder, just need it to sort of wick through that hole. Yeah, that looks pretty good. I'll do the same with this one. Don't need too much. I don't want a big mountain of solder on there. Gotta be careful I don't melt my little LED. Again, just a little bit in there, not too much. Oh, I have got a bit of a... Why's that gone cold? 350. Shouldn't have gone cold. Let that wick through. Right, that's good. That's where my wires are going to solder onto. So here's the clever bit. We bend that one back that way. Now, unfortunately, that does go across the LED, as I was saying. That one goes that way. That one we bend that way. And we solder wires. Oh, that's tipped around a bit. I don't want that. Solder the wires onto there. Mustn't forget my little link in there for the black wires. Yes, I think I've got the staggering of that correct. See if I've got any wires. Oh, I forgot I had these. Fantastic, look at this. All these pre-cut lengths of wire, these were for the PWM5s when I was manufacturing them, pushed into a piece of Corex. This is corrugated plastic. They use it for estate agent signs, you know, when you're selling your house, because it's kind of rigid, but it's got these flutes, these holes, and I pushed all these wires into here to straighten them, because of course they've got a curl on them when they come off the reel. But this is fantastic because all of these, they've been in there for years and they're all going to be dead straight, having sat in, oh look at that, having sat in there. So I need 4 wires, 2 blacks, and they're all, you know, neatly ordered in here, a red and a yellow, and I'll strip them back and solder them onto there. Oh, this is fantastic. So how did I do this? I think I pre-tinned these legs and I ran it right along, so you've got a good amount of solder on there. Run it right along, leave a little bit of a blob at the end. Then I'm going to strip these wires back and tin them, and then I don't need to feed any more solder in when I attach the wire to the leg, and you get a really good connection because it's the full length of that, which is about 8mm, and that's going to take the current. I mean, these things, this is 14 amp wire, but it's only going to take 5 or 6 amps because that's the maximum rating of this. Really, it's all about how warm this MOSFET gets. So yeah, 5 or 6 amps. I used to know all this stuff, exactly how far to trim back these wires Was it 6 or was it 8? Do you know, I can't remember. Let's go for 7. I don't remember it being 7, but that looks about right. Yeah, so that'll again get tinned, and then that will lay, well the black one won't, but I'll do a red and a yellow one, and it will lay on that leg, and that's my high current connection. Right, so I tin this wire. Probably should have been a bit shorter than this actually. That's probably too much of a blob, but I seem to remember I did put a blob on them, and then yeah, maybe there's a bit too much, and then it's just a case of laying that over there and running it along so you get a really good anchorage. I'll just lift that up near the camera. So there it is, that's the high current connection between the red wire and the MOSFET leg. So that's 12 volts, can be as high as sort of 14, going into the circuit. Then I want the yellow wire on there. Then I'll put my little, actually I might put my link wire in now before it gets too congested here, and get the black wires on, and we're pretty close. Now I can't remember what I used for the little link wire, but these 1N4148s, I think I'm going to have to sacrifice them because the wire looks about right. So let's cut that off and bend that. Now I really want this to sit fairly flat, so where are my pliers? So if I put those right in the end of the pliers, I don't know, that might be a bit of a wide span. No, that might work. Yeah, actually, you know, I seem to remember I made a load of these up. But anyway, that one will do. And then that fits through these two holes, like so. And then I solder that. I could solder that from the top, actually, couldn't I? And then the two legs poking out will take the two black wires with that soldering, that long joint technique to get the good high current connection. So let's get all that done. And there it is. There are my 4 wires soldered onto their anchor points. And then once I put these bits of heat shrink sleeving on and shrink them, I can push these down. And then I need to put the diode across there. And that's pretty much it. And then I've got to think about the conformal coating. And I might use that UV glue for this first one because I happen to have it. And I'll give it a bit of torch. But if this thing's sitting outside, because I've ordered some heat shrink, some 1/2-inch heat shrink, clear, which will go around this thing. And then I'll fill it with, I don't know, either silicone or the hot glue or whatever I feel like. But I think what I'll do is I'll seal this first with a conformal coating, so that UV glue will work fine for that. Yeah, so let's get the heat shrink on there, and then I'll power it up, actually, put some power on the red and black and fire this thing up. Right, that's the heat shrink heat shrunk. So now I can push these down as flat as they'll go against the back of the board. They won't go terribly flat because it's covered in components, but that's pretty much it. So I think I'll put some banana plugs on these actually, because I've got a solar panel and battery arrangement set up outside. It's getting on in the afternoon, but I think I could get this out there and actually doing something, and it'll survive one night out there. I can just dab it dry in the morning. Yeah, I'll put some banana plugs on it. Okay, let's just try this first on this little lead acid battery. Let's plug that in there. Oh, that was touching all that metalwork. Blue light comes on as a sort of boot up, and then we're looking for the flashing. 1, 2, 12 volts. Oh, lots of little flashes. So we're about 12.8, 12.9, which is not surprising because this battery's been on charge outside. But yeah, that's working quite well. That's pretty good. The question is the MOSFET actually going to be driven? So let's put a socket on there and take it outside and put it on the solar panel. So here it is outside, connected to the battery. I must admit, covering that LED now seems like quite a bad idea. Let's count the pulses. Now you may not see them very well out here because the 1, 2, 3, so 13-ish volts. Okay, let's plug the solar panel, which is there, into this thing. Gotta be careful not to short this end because there's no diode in there to protect against a short across there. 13.1. Let me get my hand away from the solar panel. 1, 2, 3, 2. So that's charging up. If I leave that for a while, that might start modulating when that battery gets up to 13.5. I'll come back when it does. Right, I've just tipped that solar panel up on a piece of wood there, and yes, it's modulating. It's not easy to see because the shutter on the camera, oh focus will you, makes it look a bit flickery, but yeah, that's modulating away nicely. So yeah, that's modulating away nicely. If I turn this over, we can see the microcontroller and MOSFET on the top. The wires are a bit solid, but yeah, that looks pretty good. So when that's got its conformal coating on and it's waterproofed, and then a little bit of clear heat shrink encapsulation, perhaps a slug of glue at each end, that should weather the storm out here. Lovely. And now I've put a little voltmeter on the battery, so the controller is modulating away, and the voltage at which that modulation takes place is, well, it's a bit low. It's supposed to be 13.5. It's 13.275, but that's fine. That will keep the battery nicely topped up with that thing modulating. And then if the solar panel loses light, which I can simulate by just putting something over it, that will stop modulating, start flashing the voltage again. 1, 2, 3, about 3, 13.3. It's reading high, and that's now dropping away, as you would expect when it's no longer getting energy from the solar panel. Awesome. So I think I'll leave that set up here with the solar panel acting as a sort of roof, and leave it all night tonight, and just see how we're doing in the morning. Give it an overnight test. Of course it won't do anything overnight, it will just flash the voltage, but yes, at the moment it's modulating. As I say, it's probably, the panel's a bit big for that battery, because that panel can probably generate close to an amp. I'm not sure what the charging current recommended is for that battery, but an amp's probably alright, I guess. Yeah, so for the moment, yeah, I'm happy with my project. Cheerio.